Okay, my friends, multi-step equations. This is the major one. This is what everything we worked on comes down to. And like I said in the last video, I ended off saying it, if you master equations, you've mastered the test. If you mastered multi-step equations in particular, you've mastered the test. Because almost everything we do from this point forward and all the advanced algebra questions that they ask is probably going to involve some sort of equation in it. So prior to this, we were going over one-step equations. The purpose of just going over one-step equations first was to master the movement of something over the equal sign, right? And determining when to move that. That is going to be extremely important here. So please look at the video prior to this called one-step equation in order to master multi-step equations. Multi-step equations, it says it in the name, all it is multiple steps involved in that equation. So they have a good example here. I feel like I want to do, okay. So this is a multi-step equation, right? A lot more complicated than the one-step equations that we were doing. The one-step equations, you could have guessed what x was, like we did before, 2x plus, oopsie, that's not correct. 2x plus 3 equals 6. You could, just by looking at it, guess what x is, right? X equals 3. Obviously here you're supposed to do the minus 3, you're supposed to do a mathematical approach in order to come up with this final answer, but just by looking at one-step equation you can determine what the answer is because it was pretty straightforward, right? Multi-step equations, all that gets thrown out the window. You'd have to do a lot of guess and checking and be very, very thorough to determine just what x is, what x needs to be so that when you do that whole operation it comes out to 25. This is why multi-step equations, this is why algebra comes into play and why everything we've done up until this point comes into play. So just like the one-step equations, what's the first thing you need to do? You need to find and locate your equation, your equal sign I should say, and split it. That separates two sides, right? Two barrios, two blocks, two neighborhoods, whatever you want to think of it, two countries, two worlds. And our end goal, my friend, is to find x, yeah, but in a way that separates letters to one side, numbers to the other side. That's our end goal. So I do want to write a couple steps up here that I think will be extremely helpful. If I were to add this here, we are going to do step 1. Step 1, well, I already did it actually. You split the worlds. That's our first step. That's our little line that we did. Okay, step number 2. Step number 2 is simplify each side. So this is where our pre-algebra comes into play. This is where everything that we did, simplify each side, comes into play. We've already mastered how to combine like terms, aka add or subtract polynomials, how to multiply polynomials, how to divide polynomials. We know our basic addition or subtraction or multiplying and dividing of whole numbers. We know everything up until this point. So what we need to do to solve multi-step equations, specifically for step number 2, is simplify each side. If this is side A and this is side B from our split that we made originally, what we want to do is sort of ignore side B and just focus on side A first. And what do we need to do in particular? What we need to do is simplify, as in do whatever it is that's needed to get whatever it is on this side and make it a little bit smaller, if possible. If we look at that, we could determine something. We look at it and we're just like, whoa, wait a minute, this is simplifying polynomials. I see two like terms, I get to combine them. That's exactly what you need to do, is locate any like terms, combine them. If you see any dividing of polynomials, divide them. If you see any distribution, distribute. Here it's all on you guys. You need to use your skills of math to simplify each side. So in this case it involves like terms. So let's simplify these like terms. Let's combine these like terms. 6x minus 2x gives me my 4x. This is a loner, just gets dropped down, right? All right, still focusing on side A. Is there anything else that I can do just looking at side A? No. We've simplified. We're done. So then we move on to side B. Side B. Is there anything we could do in side B? No, it's just a number. It's just 25. This is a good example of how sometimes there is nothing to simplify on each side. Sometimes both sides will be able to be simplified. Sometimes only one. Sometimes the equation that they give you, you can't even simplify each side. You just have to move on to step number 3. But step number 3 to come in a sec. In this case, you can't do anything on side B. Boom, boom. Each side is simplified. Now we move on to step number 3. So step number 3. Step number 3, my friend, is move like terms to designated side. Move like terms to designated side. What do I mean by that? What I mean by that is this. If we look here, every equation is going to be different looking, but it's all essentially the same thing. All we want to do is move, in this specific case in step number 3, is polynomials with polynomials and numbers with numbers. All right. So in this case, if you really look, I see a couple terms everywhere, right? I see a polynomial here, I see a number here, and I see a number there. In this case, 2 numbers and 1 polynomial. Just look at it, and you can clearly see that, right? We have polynomial, number, number. All we want to do is move, using our skills that we did with one-step equations, move terms with each other. In this specific example, I see, in this specific example, I see that numbers want to be with numbers, right? That would make the worlds happy. And polynomial is a loner for now, right? But it doesn't make sense to move the 4x over there because polynomials hate numbers, and they're not like terms. They are not the ones that want to be huddled up with each other. Right now, the numbers want to be together. So what needs to be moved? It doesn't make sense to move the 25 over there because then you're just moving everything to one side. Remember, polynomials to one side, numbers to the other side. So hopefully you got it. We want to move the 5 over with its friend, the other number, because if we did that, we end up getting 4x alone here, right? And then we have 25 minus 5, and that gives me my 20, right? Now we see polynomials to one side, numbers to the other. That's what we're going to do. In this specific example, all we had to do was move one number, and now we get to move on to step number 4. We're going to do multiple examples coming up that there's going to be multiple movements. But for now, this was just an example of how, like, your overall idea with step number 3 is move all the like terms with each other. In this case, the number with numbers, right? But separate from polynomials. That is why the 5 went over there. So, my friends, step number 4. Step 4, I think that's the last one, this is always going to be your final step, is once you've moved your like terms to its designated side, polynomials on one side, numbers on the other side, you are always going to divide. This was straight from the one-step equation problems. Almost always you're going to be dealt with a one-step equation that involves dividing for your final answer. So in this case, you divide by 4 on each side, and we end up getting x equals 5. Pretty straightforward, huh? Hopefully it was. If you use your steps, it is. We're going to do another example, but there's one last thing you must always do. You, with your worksheet, should never be anxious. Once you turn it in, you should never be anxious and waiting. Did I get it right? Did I get it right? Did Neil give me 100%? There's an easy way to determine whether you got the correct answer here, and that is this. If this was your final answer for X, use your skills of evaluating expressions, which was, lessons way back that we did. Go look at the evaluating expressions if needed. But get your value for X and plug it into the original X's of your multi-step equation. This is what I mean by that. If we get our X and put it, let me rewrite the original equation. Oopsie. Yeah. Just because everything looks a little too cluttered up here. If we were to get X, our new value for X, which is 5, and plug it into X using our evaluating expression technique, which was, if you recall, first substitute all letters with parentheses, and then plug in our 5, and we put inside A into the calculator, 6 over 5. There's a video explaining how you could download the GED calculator so you could have it digitally like this. It'll look identical. The version that you download looks identical to the real GED calculator. Mine's just an instructor model. So we get 25. All of this became 25, and you know it came out to 100% 25 because you copied it exactly the way it is onto the calculator, and you let the calculator do the hard work for you. So 25 equals 25. That's when you know you found the correct value for X, because both sides are equal to each other. Always check your answer at the end. Whatever answer you get for X, plug it into the original equation problem. Let's move on to another problem. So, a little bit more challenging one. I'm just going to make this one up and hope it doesn't come out as a decimal, but it might come out as a decimal. Doesn't really matter. Okay. Here's a nice little equation. Let's solve this. What's step number 1? Split the worlds. Boom. What's step number 2? Simplify each side. Let's focus on side A first. What can we do on side A? Well, I immediately see distribution. Boom, boom. And I come up with 2x plus 6, right? Bring down the plus 4. Is there anything else I can do here? Yes, there is something I can do. I can do the plus 6 plus 4. Like terms. Combine like terms, right? And we end up getting 2x plus 10. Is there anything else I can do in side A? No. So I move on to side B and I simplify side B. Is there anything I can do in side B? Let's see. Yes, I see combine like terms again. I see 2 like terms that want to be combined. So what do we end up getting here? Well, this one's a 1x minus 6x. That ends up giving me negative 5x plus 3 because I bring down the plus 3, right? If I'm going too fast, it's because you probably have not mastered all the lessons prior to this. So please go look at those lessons. Make sure you got your simplifying polynomials, multiplying polynomials, and dividing polynomials down along with your one-step equations. So we bring that down. Anything else I can do on this side? No, we're done. So let me just bring it down and align it with this guy here, the side A. This is my new equation so far. That was step number 2, simplify each side. Step number 3, move like terms to designated sides. So this is what a good example that I wanted to go over is what happens in this specific case. Remember, polynomials want to be with polynomials on one side, numbers want to be with numbers on another side. Doesn't matter really what side, as long as you just keep that in your head. Polynomials with polynomials, numbers with numbers. As long as you master that, you're good. So you tell me what needs to be moved. What wants to be moved? Well, in this case, you have multiple options. You could literally tell me the 2x wants to go with the negative 5x. And then, Neil, make sure you move the 3 over there with the 10. So the 2x comes over here and the 3 goes over there. That's one way, and you're not wrong. You're 100% right. But you're also not wrong And you're 100% right if you decided to move the 10 over there to the 3 and then the 5x over there with the 2x. Either way, you're fine. Or if you were one of those that literally want to be starting over here and say the positive 3 wants to go over there with the 10 and the 2x over here. Doesn't matter what you do first. Doesn't matter where you start or which one you want to move. What matters is that at the end of the day, you decide to move polynomial to the with a polynomial and a number the opposite side with the other number. So let's stay with the first version. The 2x, I'm going to move it over there with the 5x. And then obviously vice versa, I'll have to move the 3 by default over there with the 10 because it wouldn't make sense to move the 2x over there with the negative 5x and the 10 over there with the 3 because then everything's on one side, which is a no-no. So 2x over there to the negative 5x. Well, how do I do that? So this is another new one for you. Here, students are always like, don't you divide by 2? Because you said, Neil, when the 2 and when the number is smooching with the letter, that is when you divide, right? No. Dividing is the last step. Dividing is used to separate the number from the letter, all right, to just get the value for x, and that comes the next step. In this specific case, I'm trying to move the whole polynomial over there with its friend, the whole polynomial, negative 5x. How do you move the whole terms? It's the same as the numbers, the opposite of the sign. If this is a positive 2x, I'm going to minus the 2x, cancel that out, and throw it over there. All right? If you want, you could rewrite everything now along with the new answer. You could do that before you decide to move the 3. It's totally fine. Negative 5x minus 2x gives me negative 7x plus 3. And then now you could do the movement of minusing the 3 and throwing it over there. Because remember, always the opposite of the sign. This is a positive 3. I got to do minus 3. 10 minus 3 ends up giving me 7 equals negative 7x. And you're done with step number 3. You have a number on one side and a polynomial on the other side. Boom, easy peasy, lemon squeezy. What's my final step always going to be? Like I said, divide. Make sure you're always going to end up with a one-step equation that requires division. To leave the x by itself, you must divide by the same number. And then when you calculate this on your calculator, you end up getting negative 1 equals my x. So you just solve for x, which is negative 1. What are you going to do always after this? Check your answer, my friends. You're going to get this negative 1 and go back to the original equation right there. And wherever you see an x, you're going to put the negative 1 in, which we're going to do. This one's a lot more challenging because there's a lot of x. Let me erase all this so we go back to the original equation. Okay, I see this and I'm going to substitute wherever I see an x with the negative 1. And if you recall, the rule says always make sure you put parentheses in place of where you put wherever you're going to substitute that letter with the number. Boom. Now we solve each side and make sure each side comes out to equal to each other. So if I were to put this into the calculator, the side A, let's say, 2 parentheses, negative 1, close that parentheses in the negative 1, plus 3, close the whole parentheses, then plus the 4. This is my side A. I'm going to get 8. Perfect. I'm going to go to side B, and I'm going to copy all of this, right? And in hopes I get 8. If not, I messed up big time. Negative 1, parentheses, plus 3, minus 6, parentheses, negative 1, parentheses. Enter. Look at that, I got an 8. Does 8 equals 8? Yes, sir, which is why negative 1 is the correct answer for x. and you know 100% even before I even sent you the graded worksheet that you got this answer correct. Okay, my friends, that was multi-step equations. Pretty straightforward. It's just 4 steps that you need to master. You're going to get the vibe, you're going to get this down, and then you're going to actually end up enjoying this, trust me. So make sure you do the worksheet. Send me any messages if you have any questions, and I'll see you on the next one.